Hi, this is Brain. Today we'll be discussing on how to use the most frequently used logic blocks. So let's get started. First, we have to make sure that your soft PLC is up and running, and it is. So now we go to formation, and I assume from the previous sessions that uh, you know how to go online, you know how to access the online PLC, and you already know how to create your program block. So now we are in the network tree. So we just have to go into our program block called prog1. Now we have this workspace that we can start creating our program. So the discussion for today is about the logic blocks. From below, you see F4, logic. We click on logic. Now we have AND gate, OR gate, XOR, NOT, SR, RS, R trig, F trig, shift left, shift right, rotate left, rotate right, AND gate. Okay, and then window, zoom selected. So we also have discussed how to declare a local variable. Anyway, let's now declare a local variable called in1. Enter. Change this to boolean. Add. Now we have a new local variable called in1. Data type is bool. We have to put in an input number 2 local variable. We say in2. Add. OK. And then let's say we put in an out local variable for the AND gate. So let's call it out1. Boolean add. OK. Now we have an AND gate with two inputs, which is input in01, which is tied to local variable in1, inputs in02, which is tied to local variable in2, output out1, which is also tied to the local variable out1. Okay, let's go online. Online, display real-time data. Okay, now the truth table of an AND gate is both inputs in1 and in2 should be true, and your output will be true. So the input is in2 is false, and you have an output false. Let's change this to true. So we just made the first input true, the output is still false. Let's make the second input true. Now you have a change in state of the output. Both inputs are true, the output of the AND gate becomes true. So that's how the AND gate works. Let me just change the state of the first input to false. There. That's how an AND gate works. Let's quickly add another logic block, which is the OR gate. Again, this is also a commonly used logic block. Let's call the input, let's define a new variable which is called n3. Add another variable n4. Add. And an output variable, we call it out number 2. Add. Okay, now we go to online, display real-time data. Let's now go to the OR gate. Let me just window zoom out a bit. So now let's go to the OR gate. The OR gate truth table says if any of the input of the OR gate is true, the output will be true. So now in 01 of your OR gate is actually a false. in02 of your OR gate is a false, thus giving you an output of false. Let's change now the logic state of in01 of your OR gate to true. Let's make it true. If you can see, the output of your OR gate has changed to true. If you make the second input true, well, it remains true. If you make it the first input as false, still the output is true because one of the inputs is true. If you make it false, now the output of your OR gate will change to false. A very common logic which is also used frequently is the SR. Okay, now let's define the local variables for our SR. S1 we define in number 5. It's also Boolean. For the R input of your SR, let's say in number 6. It's also Boolean. And then the output of your SR, let's just define a new variable called out3. Add, it's also Boolean. Okay, the truth table of the set reset flip-flop in a nutshell, this is actually a memory function block where it memorizes the last transition of S1 from false to true and makes it transparent to out. And then to reset the out, you actually have to give a pulse to the R block. Now let's demonstrate this in an example. Display real time online. Okay, now let's focus in our SR function block. Let me just give it a zoom. Okay, now let's focus in our SR function block. If you can see, our SR function block input set S1, the logic state is false. R, the logic state is false. Your output is false. Now we change this input to true. We'll make it true. If you can see, the output of your SR logic changed to true. It followed the input. However, even if you make this input to false, the output remained true. As mentioned before, the SR memorizes the change in state from false to true of the S1. So when it changed from false to true, it memorized that the true value. Even if the input of the SR input S1 has returned to false, the output is still true. How do we reset that? That's why there's a reset input knob, which is just give it a true. If you give this a true, if you can see, the output of your SR has changed to false. Let's reset back the input R into false. The output remained false. So this is what it is. The SR actually memorizes the last true value of your input S1, and then the R will reset that output by giving it a pulse or a true. Let's zoom out. Okay, so now we have covered the 3 logic blocks. three commonly used logic blocks. You have we covered the AND, the OR, the SR. Let's cover R-trig. R-trig stands for rising trigger. Rising trigger. So this is going to be in 7 boolean, and this is going to be out 4. Now the function of the R-trig is actually to catch the change in state of the clock input from false to true. That's why it's called R-trig, rising trigger, false to true, and then it will make the output true if there is a transition from false to true in the R-trig clock input. Let's show this by example. Okay, now let's make this true. If you can see, there was a transition from false to true in the clock input of the R-trig. The output changed state from false to true in a bit only for a while. Let's put the input back to false. So for transition from true to false, the output is always false. Now we make a transition now again from false to true. False to true. There. Did you see the output? The output actually changed state from false to true. It went true for a while. Now we put back the input to false. The output remained false. So this is the function of the R-trig. R-trig means rising trigger. This output will trigger if the input is rising from false to true. The opposite to R-trig is actually F-trig. So let's go down and go back. So let's use the same input in 7, but let's use a different output. That's out 5. Display real time. Okay, now we have let's focus on the difference between R-trig and F-trig. Okay, now if you can see, they have the same inputs, which is showing false. They have different outputs. Output 4 for R-trig, output 5 for F-trig. Now I will change the input logic into from false to true. So what is that? That's actually a rising trigger. So if I change this now from false to true, if you can see, the output of R-trig changed to true for a while. However, the output of F-trig remained false because this detected the change in state from false to true of the input because it's rising trigger. False to true, it's rising, it's going up. Now let me change the input value from true to false and watch the output. There you are. Now when we change the input from true to false, there was actually a falling trigger. It was a falling edge. So it's the F-trig block that got triggered and the output became true. Let's do it one more time. False to true. R-trig became true for a bit, and then true to false. F-trig became true for a bit. So that covers our discussion for very commonly used logic blocks in in the logic group, we have the AND gate, the OR gate, the set reset flip-flop, the rising trigger, and the falling trigger.